topic again. Okay. We were discussing about how the gases exchange takes place in the alveoli of the lungs, right? So there are three principles upon which the gases exchange takes place. Principle 1 is oxygen and carbon dioxide are carried by the blood. And 2 is gases move by diffusion, that is, they move from an area of higher concentration to an area of lower concentration. And 3, the lining of the alveoli must be moist to help gases diffuse. Okay? So how does the diffusion of oxygen and carbon dioxide take place? In the alveoli, the respiratory and circulatory systems, they come together in the process of gas exchange. Okay, for this gases exchange takes place, it is not only the respiratory but also the circulatory system which has to work. So when you inhale, the air flows from the bronchi to the bronchioles and finally into the alveoli. Okay, so we all know what are bronchi and what are bronchioles. So these are the bronchi which open into many branches which are known as bronchioles. Okay, so when you inhale, the air enters the lungs through the bronchi, and from there the air enters the bronchioles. Okay, and finally into these tiny structures known as alveoli, which are present at the tip of each bronchiole. Okay, a cross section of a bronchiole and several alveoli are shown in this picture over here. These are the cross section of alveoli. You have the same picture even in your textbook on page number 857. Okay, so each alveolus is about the size of a grain of sand, but all of the alveoli together give the lungs a surface area of about 100 square meters. So it is the alveoli which increase the surface area of lungs and which help in the exchange of gases. Each alveolus, it is only about the size of a grain of sand. So without this huge area for gas exchange, the lungs would be unable to extract enough oxygen from the air to keep you alive. So this huge surface area, it is very, very important for us to absorb the oxygen from the air. Okay. A complete network of capillaries surrounds and penetrates the alveoli as shown in this picture here. You can see these capillaries which are surrounding the alveoli. Blood entering these capillaries contains a lower concentration of oxygen than does the air in the alveoli. As a result, the oxygen diffuses from the area of higher concentration in the alveoli to an area of lower concentration in the capillaries. Okay, so the blood which is flowing in the capillaries, it has a lower concentration compared to the blood which is present in the alveoli. Okay, that means oxygen-rich blood, it is present in the alveoli. So because of this diffusion takes place and the oxygen, it diffuses from the area of higher concentration, that is from the alveoli, to the area of lower concentration, which is the capillaries. The blood in the capillaries, it contains RBC, a type of cell that picks up oxygen in the lungs and delivers it to all the body cells. So what does the blood contain? Obviously, there are RBC, WBC and platelets present in the blood. So the RBC present in the blood in the capillaries, what do? They pick up the oxygen in the lungs and deliver to all parts, all the body cells. So in RBC, most of the oxygen molecules bind to an iron-rich protein called hemoglobin. Now, do we all know what is hemoglobin, girls? What is hemoglobin? Can someone please tell me what is hemoglobin? Yeah.
It's the red blood cells.
It is the red blood cells itself?
Yeah.
Now, is it present in the red blood cells or is it the red blood cells itself?
It's the iron-rich protein.
Yes, it is the iron-rich protein which is present in the blood. What does it do? It transports
oxygen.
Right, yes. It is a protein in your RBC that carries oxygen to your body's organs and tissues and transports carbon dioxide from your organs and tissues back to your lungs. So it is the red pigment which is present in the blood which gives its red color. Not only that, it is also a protein which helps in the absorption of oxygen. Okay, so this RBC, most of the molecules, they bind to an iron-rich protein called hemoglobin. Each molecule of hemoglobin binds with 4 oxygen molecules, and the iron in hemoglobin is what gives blood its reddish color. Okay, so each hemoglobin molecule, it binds with 4 oxygen molecules, and blood becomes bright red only when it absorbs oxygen. So if you can see the blood in the arteries, it is bright red in color because it is oxygen rich blood, whereas the blood in the veins, it is little darkish red or little blackish red in color. Why? Because it is deoxygenated blood. Okay, so the blood leaving the alveoli, it carries almost 3 times the amount of oxygen that it had coming into the lungs. So when the blood was coming into the lungs, it did not contain oxygen, but when it leaves the alveoli from the capillaries, so it picks up oxygen from the alveoli, and this is oxygen-rich blood now, which is carried to the various cells of the body. In contrast, carbon dioxide concentration are higher in the blood than in the alveoli. So as a result, carbon dioxide diffuses into the alveoli. Okay, so the carbon dioxide concentration is higher in the blood than in the alveoli. So the carbon dioxide, it diffuses into the alveoli, and the higher concentration of carbon dioxide in the blood is due to the fact that every cell produces carbon dioxide and water as waste products. So the carbon dioxide and water combine in the blood to form the compound carbonic acid. The more carbonic acid there in the blood, the more acidic the blood becomes. So when carbonic acid diffuses into the alveoli, the compound separates into carbon dioxide and water, which are exhaled. Okay, so this is how the carbon dioxide and water, which is waste, is collected from the rest of the cells, and it is taken back to the alveoli, wherein the carbon dioxide is exhaled out from the alveoli, from the lungs outside. Okay, so this is how the exchange of oxygen carbon dioxide takes place, and this is also how it is carried from the blood, and from the blood itself the carbon dioxide reaches the lungs in the form of carbonic acid, and in the alveoli the carbonic acid, it separates into carbon dioxide and water again, and carbon dioxide is exhaled out. Is it clear, my dears? Any doubt you have from this topic? From the exchange of gases? Girls, is it? Yeah. Do you want me to repeat? Do you have any doubts? Is it clear how it happens? Hello? Yes? Okay, the entire, yeah, thank you so much. Procedure is given over here, my dears. You may go through it. Okay, so this is about how the gases exchange occurs in the alveoli of the lungs. Okay, gas exchange and nervous system is our next topic. So before that, let me ask you a quick question. How might a sudden rise in the carbon dioxide in the blood affect the gas exchange process? When there is a sudden rise in the carbon dioxide in the blood, does it affect the gas exchange process, girls?
Yes.
Yeah. Then what happens? What happens when there is rise in carbon dioxide in the blood? Obviously, the rate of gas exchange, it will also increase, right? It will increase in order to bring in more oxygen into the alveoli. Okay, so whenever there is more carbon dioxide concentration in the blood, the rate of gas exchange, it becomes more faster, it increases, and it brings in more oxygen into the alveoli. Okay, my dear, so let's move on to the next topic, which is gas exchange and the nervous system, as to how does it affect our brain. So gas exchange is critical to the body, that is an autonomous function. It is an autonomic function, meaning it happens automatically. It is regulated by the medulla and pons in the brain stem. Okay, let me show you the... Give me a minute. Okay, so these are the various parts of the brain which you can see on the screen here. Okay. Okay, so you can see this is the midbrain. This is the medulla oblongata. This is the pons. Okay, and this is the spinal cord. All right, so this gaseous exchange, it is an autonomic function. It is regulated by the medulla and the pons in the brain stem. So this medulla and the pons, medulla oblongata and the pons, they help in regulating the gas exchange. So these centers, they monitor dissolved gases in the blood, particularly carbon dioxide concentrations. As you become more active, carbon dioxide levels increase and the blood becomes more acidic. That means more carbonic acid is present in our blood when the carbon dioxide level in the blood increases. So sensors, the respiratory and circulatory systems signal this change to the brain stem. The medulla sends messages through the nervous and endocrine systems that stimulate the diaphragm and ribcage muscles to work harder. So this was the question I asked you. So whenever the carbon dioxide levels in your blood, they increase, immediately the blood becomes acidic because there is more carbonic acid. So a signal is sent to the medulla and the pons in your brain. So as soon as they receive the signal, what does the medulla do? The medulla sends messages through the nervous and endocrine systems that stimulate the diaphragm and ribcage muscles to work harder in order to get more oxygen. Okay, so the medulla, it regulates how often and how deeply you breathe based on your activity. That is why when you're doing any vigorous exercise, you breathe more faster and more deeper. Why? Because providing your body with more oxygen. Okay, because whenever you do more activity, your cells are working more harder and the carbon dioxide levels in the blood increase, and in order to bring in more oxygen, in order to remove the carbon dioxide from the blood and bring in more oxygen, you breathe in more faster. For this, your diaphragm and your breast muscles, they work harder and you breathe in more. Okay, so this is what happens when you do any vigorous exercise or any activity. Clear, my dears, about how the gas exchange and nervous system are related? So which are the two organs in the brain which control the gas exchange? Girls? Which are the two organs which help in gas exchange in the brain? Fatina? Yes, pons and the medulla oblongata. Okay, this one.
The midbrain?
Yeah, no. This one. This oblongata which you see here, this is medulla oblongata and this is the pons. Okay, let me ask you a question before we move on to the next subtopic. How does the alveoli structure relate to the function of gas exchange? You think the structure of alveoli plays a role in the gas exchange?
Miss, can you repeat the question?
How does the alveoli structure relate to the function of gas exchange? You can see the structure of alveoli here. How does it relate to the gas exchange? Okay, alveoli being very small and being surrounded by capillaries, and they are only one cell thick, that it allows for easy diffusion between the alveoli and the capillaries. As they are very tiny structures, as the size of the grain of sand, and they are also surrounded by capillaries. They not only increase the surface area of the lungs, because of their tiny structure, it makes it easy for the diffusion between the alveoli and the capillaries. Okay, so that was the answer to this question. There is one more very interesting story here. You want to, okay, it will just take a minute for me to read it out. Garnet A. Morgan was the son of former slaves whose formal education never went beyond elementary school. So with hard work and an intermittent mind, he went on to become an inventor and businessman. In 1914, Morgan invented the gas mask. The mask consisted of a hood with two attached tubes. One tube extended to the ground and was plugged with an absorbent material that filtered the inhaled air. And exhaled air was released through the second tube. Okay, so it was Garnet A. Morgan who invented the gas mask in the year 1914, though he was not very well educated. In 1916, an explosion in an underground tunnel below Lake Erie trapped 32 men in debris, dust and smoke. So Morgan and some volunteers used his gas mask to rescue these men. Morgan's gas mask was refined for use by the U.S. Army during World War I and saved several hundreds of American soldiers. So this invention, it proved to be very, very useful during 1916 when there was a gas explosion and many people were struck underground and they were saved because of these gas masks. Not only that, it was used a lot in the World War I. Okay, so it was Morgan who invented this gas mask. Now, quickly move on. Shall we quickly move on to the next subtopic, which is respiratory diseases? They interfere with gas exchange. Now, what are the respiratory diseases? Damage to the respiratory system makes gas exchange more difficult, which in turn affects every cell in the body. So smoking is the leading cause for respiratory diseases such as the lung cancer and emphysema. Okay, so the major cause for respiratory diseases is the smoking. It leads to diseases such as lung cancer and emphysema. Now, what are these? Tobacco smoke, it contains more than 4,800 chemicals that can paralyze cilia, damage alveoli, and cause genetic mutations leading to cancer. So your alveoli in the lungs, they are damaged because of smoking. Why? Because the cigarette smoke, it contains about 4,800 chemicals in it. So you can see the effects of smoking on the lung tissue. When a person smokes for several years, the lung tissue is slowly coated by tar and other chemicals. Eventually, the tissue becomes almost solid black. The sooner people stop smoking, the sooner such damage to the lungs can be reversed. Okay, so smoking is supposed to have an adverse effect on the smoker's lungs. Can you see in this picture? This is how the healthy lung tissue looks like, and this is how the smoker's lung tissue looks like. So whenever the smoker is smoking for several years, so his tissues, they become black and they are coated with tar. They become black, coated with tar and with other chemicals. So the sooner he stops smoking, it's better for him. Otherwise, it will lead to the very serious conditions like lung cancer, which can eventually lead to death. Also, there is asthma. Have you heard of this asthma or respiratory, you can say, disorder? Girls, do any one of you have asthma here? No one, alhamdulillah. Okay, so asthma causes the bronchioles to constrict due to muscle spasms. This condition makes it hard to move air in and out of the lungs. So these bronchioles which carry the oxygen inside your lungs and which open into the alveoli, so those bronchioles, they constrict, making the gaseous exchange difficult. Okay, so a person having a severe asthma attack can die from lack of oxygen. So attacks may be triggered by allergies, stress, exposure to smoke and chemicals, or exercise. The attacks can be relieved by drugs that relax the bronchioles. So you must have seen in many movies or many people also use these oxygen pumps. Have you ever seen? The people who have this asthma disorder, they use these oxygen pumps. Why? Because whenever they blow this oxygen into their mouth, it eventually opens up these bronchioles. Okay, because asthma attack is caused when the bronchioles are constricted completely and there is no oxygen for them. There is no gaseous exchange which takes place, due to which they might even die if they don't pump in oxygen immediately into their mouth. Okay, so this asthma attack could be, it is normally hereditary. but it can also be triggered due to any allergies if the person has, or because of stress, or if he does any vigorous exercise, etc. And he needs to be treated immediately, otherwise it might lead to death. Also, there is cystic fibrosis, which is a genetic disease that causes the lungs to produce a thick, sticky mucus. And this mucus blocks the airways and allows microorganisms to thrive in the lungs. Okay, so this cystic fibrosis is a condition in which the lungs are coated with very thick mucus. And this mucus, it becomes a home for the bacteria. The bacteria start multiplying in these, thriving in the lungs. And people with cystic fibrosis, they have frequent or sometimes fatal lung infections. And treatments focus on preventing the mucus from building up. Okay, so these are some of the respiratory diseases. What are they? Which we just discussed about. We discussed about cancer. We discussed about. Okay, did we talk about emphysema? Okay, emphysema is also a lung disorder which is caused mainly by smoking. Over time, many alveoli are destroyed, and this process gradually reduces the surface area for gas exchange, and not enough oxygen can enter the blood. So people with advanced emphysema must use supplemented oxygen, but eventually their lungs, they fail. So at present, this disease has no cure. The best way to prevent emphysema is to refrain from smoking. So this is also again one other respiratory disease which is caused due to smoking, where in the alveoli they get damaged, and when the alveoli get damaged, obviously the exchange of gases, it doesn't happen, due to which there is not enough oxygen, and eventually the person is kept on ventilators. But there is no cure for this disease so far, and eventually the person will die. Okay, so these are the various respiratory disorders. One is the lung cancer, there is emphysema, asthma, and also cystic fibrosis. Clear, my dears, about these disorders? Any questions you have so far from this topic? Hello, any questions? Is it clear?
Yes.
Okay, let me ask you one question then. How does smoking affect gas exchange? What happens to the smokers? How does smoking affect gas exchange? Okay, chemicals from tobacco smoke, they damage the alveoli, reducing surface area and decreasing the lungs' ability to absorb oxygen and expel carbon dioxide. This condition is known as emphysema, which most of the smokers get after a stage, after several years of smoking. Okay, and let me also give you some interesting information. The rewards for quitting smoking are immediate. After the last cigarette, the following happens to the body. The smoker, he quits smoking, then 20 minutes after, the blood pressure, heart rate, body temperature, they drop to normal. 8 hours after, carbon monoxide and oxygen levels in the blood, they return to normal. After 24 hours, the chance of heart attack decreases. After 48 hours, nerve endings, they start to regrow. So as in when the person, he stops smoking, his body becomes healthier and healthier. And after 1 year, the cilia in the lungs, they begin to heal, reducing the infection. And after 5 years, lung cancer death rate for a former average smoker drops almost as low as the rate of a non-smoker. So if you have any smokers at your place, please discourage them, because even now there is a chance if they stop smoking, they can regain their health back. Okay, my dears, so let's stop at this note. Thank you for reminding me that the class was not getting recorded. You have a great day ahead.